All right, welcome. Today we are diving into something really fascinating, a system that's trying to solve a massive problem. How do you actually prove something happened in the real physical world? I'm not talking about just having a witness. I mean proving it with unbreakable cryptographic certainty. We're going to explore how to build this chain of trust, starting from a machine's bare metal all the way up to a human's credentials to create a permanent, verifiable record of physical truth. Let's get right into it.
So it all comes down to this one giant challenge, the Oracle problem. You know, blockchains and digital ledgers are fantastic at keeping perfect, unchangeable records, but they've got a blind spot, a huge one. They're basically blind and deaf to the outside world. They have no way of knowing if the data they're getting from a sensor, a machine, or even a person is actually true. This system, well, it aims to give that ledger eyes and ears it can finally trust.
Now, to really get a handle on the solution here, we first need to understand the philosophy driving it. It's about shifting away from the kind of fragile top-down systems we all rely on now and moving towards something that's just fundamentally tougher and more resilient.
And this slide just lays it out perfectly. On the left, you've got linear fragility. Think of it like a chain, or even our power grid. If you cut that one line, if you break one link, the whole thing just goes down. But on the right, that's the goal, spherical resilience. It's not a line, it's a web, a mesh. Every single node is its own self-sufficient civilization in a box. If one of them goes offline, who cares? The network as a whole is just fine.
Okay, so if you're building this world of tough, independent machines, the very first question you have to ask is pretty obvious, right? How can you possibly trust the machine itself? How do you know that it is what it claims to be?
Well, the answer is something called a hardware root of trust. And the key word there is hardware. This isn't just a piece of software you can copy or hack. No, we're talking about anchoring a machine's digital identity to its actual physical makeup, its atoms, making it as unique and impossible to fake as a human thumbprint.
And here's how they do it, which is just brilliant. First, you've got radio frequency fingerprinting. Think of it like this. Because of tiny, microscopic flaws from when it was made, every device has its own unique radio accent or hum. It's an unforgeable physical signature. It's like a passport baked into its very being. Then, you pair that with a TPM 2.0 chip, a special tamper-resistant chip that has a private key literally burned into it at the factory. It signs every piece of data, giving it that second layer of cryptographic proof.
All right, so the machine is locked down tight. We can trust it. But, that's only half the puzzle. What about the person operating it? The human element is always the wild card. So let's look at how this system handles that, because this is where it gets really, really interesting.
Yeah, this is the real challenge, isn't it? You can build the most secure machine on the planet, but if the wrong person, an unauthorized or untrained person, can get their hands on it, then your whole system is compromised. So how do you solve for the human?
And the answer is the sovereign badge. Now, I know what you might be thinking. NFT, right? But just forget everything you think you know about NFTs as collectibles. This is a whole different beast. It's a special soul-bound token. That means it is permanently locked to one person's digital wallet. You can't sell it, you can't give it away. It's not an asset, it's an identity. It's basically a digital diploma, an unforgeable proof that you are who you say you are and that you have the skills you're certified for.
So let's walk through how this handshake actually works. And the coolest part, it can all happen completely offline, no internet needed. A technician with a tablet walks up to a machine. The machine sends out a random one-time challenge. The technician's wallet, the one holding their sovereign badge, cryptographically signs that challenge and shoots it right back. The machine can then verify right there on the spot that the signature is valid, the badge is legit, and it hasn't been revoked. It's a secure digital handshake.
Okay, so we've got trusted machines, and now we've got trusted humans. Fantastic. But where does all this verified data actually go? Where does it live? Well, it's all managed by a really clever two-part network that acts like a dual brain.
I absolutely love this analogy because it makes so much sense. The system uses two networks that work together. First, you have Hyphanet. Think of this as the permanent, unchangeable library or the system's hard drive. This is where you store the stuff that should never, ever change, like audit logs, manuals, firmware. Then you have the new Freenet, and that's the fast, real-time CPU or ledger. It handles all the live, dynamic data, like energy transactions or who's currently authorized to work on a machine.
And here's the real kicker. For that dynamic layer, that new Freenet, it uses what's called a zero-gas model. You see, on most blockchains, every little piece of data you record costs a small transaction fee, or gas. In an industrial setting, with a sensor logging data every single second, those fees would be absolutely astronomical. This model gets rid of that cost completely, which makes it economically possible to create this constant, verifiable stream of data needed for things like compliance.
So, let's tie all of these threads together. What does a world with trusted machines, trusted humans, and this dual-brain network, what does that actually look like in practice? What does it enable? The result, the big payoff for all this tech, is this incredibly powerful thing, a dual-signed object. For every single critical action, the system creates a log entry that is cryptographically signed by two different keys. One is from the machine's physical hardware proving what machine did the action, and the second is from the human's sovereign badge proving who authorized it. It's like needing two keys to turn at the exact same time. You get an unbreakable, completely auditable chain of custody.
And this isn't just some cool tech theory. The real-world impact is massive. For tough new regulations like the EU's deforestation rules, you can now provide mathematical proof of where a product came from. For the entire DePIN sector, that's decentralized physical infrastructure, this provides a whole new foundation for trust. And get this, a buyer in London can audit a farm's entire history in Uganda without a single middleman. They don't have to trust a person or a company, they just have to trust the physics and the math.
So I want to leave you with this final thought. We've just walked through a system where physical events, things that happen in the real world, can be recorded with mathematical certainty. So if we can start to build a world where truth is no longer just a matter of opinion or trust or belief, but is instead a matter of cryptographic proof, how does that change everything?